We would now like to summarize our results for impedance when we just have a voltage source that's oscillating and one element, Z. Now recall that we wrote our voltage as a complex function. We wrote our current, an amplitude, and a complex phase, and we'll write it that way. And our goal was to find I naught and phi. And we have a relationship, a complex relationship, that the voltage is equal to the impedance times the current. Now, for our various elements, let's look at them. Let's start with the resistor. And by the way, we write the impedance as a modulus and a separate phase. And for the impedance of the resistor, this is a pure real number, so that's just R. The phase for the impedance, which we've said is delta, is 0. And so if we were to just write the impedance, it's just the real number. For the inductor, L, we had that the modulus of the impedance was omega L. The phase was pi over 2. So if we wrote this as omega L e to the I pi over 2, let's keep in mind two facts, that e to the I pi over 2 is I, and e to the minus I pi over 2 is minus I. And so we can write this one as I omega L. Now for our capacitor, the modulus we found was 1 over omega C. The phase was minus pi over 2. So the complex number is 1 over the modulus times the phase. But e to the minus I pi over 2 is minus I. So we can write that as I minus I over omega C. Now, these are our values for just when we have one single element. And we'll look at next is what happens if we put elements in series.